Good morning, everybody. My name's Stephen Harkin from Delta EE in the UK, and today I'll be discussing a study that we're doing for Gas BE, looking at how gas demand will change in Belgium out to 2050. I don't speak any French or Dutch, but hopefully everybody can understand the Northern Irish accent. I'll try to talk slowly. In terms of the presentation today, I'll start with an introduction to the scope of work that we're carrying out for Gas BE. So in 2015, we did the residential analysis at a higher level to 2030, and we're extending that study currently. I'll give a bit of a starting point in terms of what gas demand looks like today in Belgium. Talk briefly about some of the drivers for change that might influence how gas demand looks going forward. And then I'll get on to some of the results. So today I'll be showing some of the early results for Flanders. And then I'll just briefly finish off with some of the next steps for the project itself. For those of you that don't know who Delta is, we're based in the UK. And we're a research consulting firm that focuses on helping our clients understand the transition from old energy to new energy. So helping our clients understand what a decentralized, distributed, lower carbon future might look like. And we do this by focusing primarily on the demand end of the energy value chain. So we typically don't look at big scale generation. We're increasingly doing work for the network companies, but our expertise is at the customer end of the energy value chain. So really understanding how customers will behave and how that behavior will change. Understanding how the markets for technologies at the customer side will evolve going forward and what that means for technology deployment. And in terms of what we do, our business is split into two parts. So we have a series of topic-specific research services. We have some focusing specifically around heat, and in particular electrification of heat and gas heating. So a lot of that expertise feeds into this study. And we do bespoke consulting as well. But in terms of the scope of the project that we're doing for Gas BE, so we're looking at gas demand for heating, looking at the residential sector, commercial sector, and industrial process heat. For industry, we're focusing on the part of industry that's connected to the DSO, so not the big TSO scale stuff. All of this analysis we're doing at the regional level, so considering Flanders, Brussels, and Wallonia separately. They all have quite different housing stock characteristics, different policy frameworks, different types of customers. So it's quite important that we do this at a regional level rather than Belgium as a whole. And for Gas B, we're looking at how annual gas demand and how peak gas demand will change going forward. So this is to feed into the forecasting and to support the DSOs and the TSO in Belgium. And in terms of the timescale, we're looking out to 2050. So as I mentioned before, the previous study we did just focused on residential heating out to 2030. But for this project, we're considering all segments and forecasting out to 2050. So yeah, that's what we did for the 2015 study, and we've extended that now for the current study. But yeah, just a few slides on the starting point for gas demand in Belgium today. And just two charts. So, and this is data kindly shared from Fluxys. The top chart just illustrates gas demand over the course of a year for the three different regions. This is gas demand per day. Unsurprisingly, we have the peaks of gas demand in the winter months, with some base load over the summer months, largely coming from industrial or larger commercial demands. And you can see Flanders accounts for the majority of this gas demand today. Unsurprisingly, it's got about half the population or slightly more than half the population in Brussels, or in Belgium, but also still quite significant gas demand from Wallonia and Brussels. And why are we looking at residential and non-residential? That gas demand is pretty much, it's close to 50-50 between residential and non-residential, so it's important that we look at both those sectors. And the winter peak, the analysis around that is quite important for planning the networks, so it's important to look at annual and peak within this study. And the regional variations in Belgium is quite interesting as well. Just briefly looking at some of the building stock characteristics. Flanders is characterized by lots of single-family homes. Quite a big proportion of gas-heated homes still in Flanders, but with some off-gas as well. And the building stock itself is some quite old buildings, but still quite a lot of modern buildings, which is a bit different compared to the other two regions. Looking at Brussels, very different to Flanders, dominated by multifamily homes. So lots of big multifamily homes, apartment blocks, which makes it quite difficult for some switching away from boilers to potentially bigger heating systems. The heating market's dominated by gas in Brussels, and you can see quite a lot of older buildings in Brussels compared to Flanders. And Wallonia, again, is different. So the highest proportion of single-family homes out of the three regions. Maybe only 40% of residential gas demand is for heating in Wallonia. Quite a lot of rural off-gas houses, so a lot of oil in Wallonia. And again, different age of the housing stock. So all of this means the starting point in the three regions is quite different, which has quite a big impact on how the story for gas demand will evolve in each of the three regions. And in terms of some of the drivers for change that we're considering in this study, as I mentioned earlier, customers in the three regions behave differently, have different motivations. So their attitudes and awareness to the decarbonisation story, to new technologies is really important in terms of what customers are willing to invest in or the decisions they make. Technology costs. So for the gas regions, it's quite difficult to compete with a gas boiler today. We can shift to more efficient condensing gas boilers, but most of the technologies, whether it's a heat pump or the lower carbon gas appliances, they're quite expensive compared to what customers are used to today, and that will have a big impact in terms of the decision making going forward. Energy prices, another big impact on the economics or the proposition for customers. Especially if we're asking customers to maybe move away from gas to heat pumps. The difference in gas and electricity price across Belgium makes that it can increase the running costs potentially. So again, an important consideration. And of course, going forward, how gas and electricity prices evolve will have a big impact on the change. A few other considerations are things like technology and performance. So how will the efficiencies today improve as we go forward? Policy and regulation, quite different across the three different regions we've found through this analysis. Quite different for how that will evolve. So again, that's going to lead to different evolutions. Installers are a critical point of this story as well. They're often the source of information and advice to customers. If installers aren't on board with some of these new technologies, again, that can be a big barrier to some of the transformation happening. Housing stock, as I mentioned, quite different across the regions, and the heating market structure as well. So these are some of the key characteristics that we're considering in this analysis. And then what can gas boilers change to? This is what customers on gas today are used to. Potentially the easiest option for them is to switch to more efficient gas appliances. But today, the main option really is condensing gas boilers, moving from a less efficient to a more efficient version of the same appliance. Gas-driven heat pumps. These have been around for quite a few years. They're starting to get some traction in the commercial sector, but still quite expensive. Only some manufacturers are starting to look to this technology, so it's quite early days. Micro CHP and fuel cells perhaps been around a lot longer. Certainly seeing success in Japan, further afield, but in Europe it's really yet to find a foothold. Again, quite an expensive technology, so this might have a place in the future, it may not. Boiler plus options. So what I mean by this is a condensing gas boiler coupled with some solar thermal, maybe some solar PV, maybe some smart controls. So these are options that are potentially lower cost, that we see moving into new builds, part of the regulations around that. But again, that could be an option for the future. And of course, simply just improving the control strategies or control systems around heating systems. That could be an easy way to incrementally improve efficiency and could drive down some of the costs. If gas boilers don't switch to gas, the key option other than that is electrification of heat. Switching to either pure electric heat pumps, so air source or ground source, or perhaps hybrid heat pumps, so a combination of a gas boiler with an electric heat pump. Electrification of heat's been increasingly on the agenda across Europe in general, and certainly Flanders is quite, of the three regions perhaps, a bit more progressive or a bit more interested in heat pumps. But again, there's some limitations in terms of the installed cost of these appliances today, and that energy price differential, which makes it difficult for these technologies to gain a foothold. Energy efficiency could be another thing which has an impact on gas demand as well, simply through better insulation in properties, or building regulations specifically on new build forcing passive house standards or much more energy efficient properties. District heating doesn't appear on this slide, but that's something else that we're considering for this analysis, and we think it will have a place in the future, possibly quite small, but it's certainly another option for shifting away from gas. Just really briefly on the methodology we're using. So all of that, the assumptions we're building around energy prices, technology prices, customers. We have a building stock model which we feed all these assumptions into. But a lot of the analysis is founded on the kind of economic performance of new technologies versus gas boilers. So we consider the payback period and the upfront cost of these appliances compared to gas boilers. We also consider how easy it is to install or fit these new technologies into the existing building stock. So Brussels, for example, where it's lots of multifamily homes, smaller floor areas, it's quite challenging to fit a micro CHP system or perhaps a big gas heat pump into those properties. And then we also consider what we call soft factors, but this is basically these issues at the bottom. So it's even if the heating system economically makes sense and can fit into a property, sometimes rational decisions are not made by customers. They might not know this technology, they might not trust it. Installers may not be promoting it. Manufacturers might not be really backing this technology. So there's some kind of softer factors that we consider as well in the analysis. So now on to some of the results or the early results from the analysis. And for this section, I'll just focus on Flanders. We're still in the process of refining this and finalizing the results for Brussels and Wallonia. But this is I guess the storyline, or most of the storyline that we have for Flanders at the minute. Focusing really on what are the key policy changes that we might see or developments in the market that might influence or shift customers onto new technologies. I'll focus just on some of the ones that will impact gas appliances. So in the short term, we're expecting some subsidies or financial incentives to shift away from non-condensing to condensing gas boilers. By 2021, the gas grid can no longer extend to new build developments. So new build gas can still occur, but we can't see any extensions of the gas grid into more rural areas for those new builds. We're expecting to see a ban or a phase out of non-condensing boilers in the next few years as well. It will take many years after that before those non-condensing boilers completely disappear, but again, that's going to drive a short-term change. By the end of the 2020s, early 2030s, this is when we'd really expect to see the new technologies, whether it's heat pumps, gas heat pumps, fuel cells, the prices of those technologies to have come down enough that it starts to become a bit more attractive, or certainly much less of a barrier for customers. Energy Pact, again, could be quite a significant impact. It's highly uncertain at this stage, but beyond the 2030 period, we think this could be quite a significant impact on this. At the minute, we're assuming it's going to ban gas and new build completely. Around the 2040 mark, it might be a little bit earlier, might be a little bit later. And we're likely to run a sensitivity or a scenario around this, assuming that that ban also applies to the existing stock, just to see what impact that might have. And something else that we are considering is the introduction of whether it's a heat pump tariff, so a cheaper electricity price for heat pumps, or some kind of CO2 tax or increase in gas price. We're assuming that the government will likely step in and try to do a bit more forcing of change. Without that, and if this is all left up to customers, then I think we'll see very little change really before 2050. So that's some of the headlines or the storyline just on gas. There's other things that will impact the off-gas market, so whether it's oil or electric as well. So what does this mean for Flanders? So from the results, this graph illustrates the installed base of heating appliances in the residential sector out to 2030. The blue at the bottom is gas appliances. The purple is oil appliances. The greeny color is electric, and a tiny bit of other, which is biomass and district heating. As you can see from this chart, not a huge amount of change in terms of the type or the fuel type of appliances out to 2030. So we're expecting gas appliances still to account for around 60% of the heating park out to 2030. We will see some change in the mix of those gas appliances, which I'll come on to in one of the future slides. But extending this so out to 2050, so this is part of the update to the study that we're doing right now. We do expect to see a bit more change by 2050. We can see gas appliances again at the bottom. We think they'll peak in the 2030s and then slowly come down beyond 2030. But we're still expecting to see quite a significant share of gas appliances in the heating mix by 2050. Perhaps unsurprisingly, oil gradually and slowly declines, but we think there still might be a bit of that by 2050. This green area, quite significant growth in that. That's driven primarily by air source heat pumps. So we expect to see a lot of air source heat pumps displacing oil boilers in the off-gas market. And we'll see a little bit of air source heat pumps getting into the gas market by 2050. So yeah, by 2050, we're expecting around 1.75 million gas appliances, so that's a little bit less than today. But we expect electric to grow to 1.4 million, so quite a significant growth in electric, primarily heat pumps by 2050. So on the next slide, I'll just focus on the gas, given this is a talk about gas conference. Let's just see what's happening in that segment. So again, this is just looking at the gas appliances out to 2030, what we expect to see happen. The bottom here is non-condensing or lower efficiency gas boilers. The purple is high efficiency condensing gas boilers, and the green at the top is lower carbon gas alternatives. So as you can see, by 2030, we're expecting to see non-condensing to almost be completely removed from the stock. And this is something that's changed from the previous study. In the previous study, we still had maybe 10% non-condensing, but we think the potentially the incentives for condensing gas boilers and the ban on non-condensing will accelerate that reduction in non-condensing in the stock. And we're expecting to see, not in the short term, but certainly maybe the second half of the 2020s, to start to see the lower carbon gas appliances gain a bit of traction. But still, we're only expecting to see around 10 or 12% of appliances being the lower carbon gas alternatives. Looking to 2050, quite a significant change. So as you can see, this is still the 1.75 million gas appliances, but we think around 50% of those will be condensing gas boilers. So remember that even when a gas boiler is installed, its lifetime might be 15, 20 years. So as long as we're installing condensing gas boilers in this period, we're still going to have quite a lot of them out to 2050. But we expect to see quite strong growth in the lower carbon gas alternatives. So we expect those costs to gradually come down and become more acceptable to customers. The efficiencies, they'll be a bit more efficient than condensing gas boilers, or sometimes a lot more efficient than gas boilers. So we'd expect the running cost savings to become more attractive. And as customers become more aware and much more comfortable with these technologies, again, we'd expect to see a stronger uptake post 2030 of those appliances. On the next slide, I'll just look at what these gas appliances are. So again, this is the same chart out to 2050, but we've just broken down that green part into these three sections now. The orange bar here is hybrid gas heat pumps. So this is a condensing gas boiler with an electric air source heat pump. The blue here is gas heat pumps. So that's a gas-driven heat pump. Quite an interesting technology. It can be 150 to 200% thermally efficient. So I think there are opportunities for gas heat pumps to look like a gas boiler, but have up to double the efficiency. So potentially quite an interesting technology. And the purple line here is micro CHP and fuel cells. So, I mean, a lot of assumptions has gone into what's driven this uptake in terms of how the fully installed costs will evolve, how maintenance costs will change, how the efficiencies of these appliances will change. So this mix it's quite sensitive to the assumptions that feed into our modeling. But we certainly see a strong role for these alternative gas appliances by 2050. We will be running some sensitivities around this. What we might see is, what I would expect to see is perhaps a scenario where the total number of gas appliances reduces by 2050. But I think that's going to require some quite strong intervention from government, which we haven't yet seen, but we suspect government will have to act in some shape or form to perhaps shift some of these gas properties to full electric, so whether it's air source heat pumps. Maybe government might intervene and encourage more district heating. But at the minute we're seeing not a huge amount of evidence to support that, but certainly we think that government will have to step in and force some changes post-2030. But what does all of this mean for gas demand in Flanders? So this chart's illustrating gas demand, annual gas demand in gigawatt hours on the x-axis, and it's broken down by technology type. So again, we have our condensing gas boilers, non-condensing here at the bottom. Condensing as the lion's share of this chart with the lower carbon gas at the top. The headline here is we're expecting to see maybe 19% reduction in annual gas demand compared to today by 2030. So again, this is a slight change on what we had from the previous study where we were projecting maybe a 10 to 12% reduction. But this is primarily driven by an accelerated shift from non-condensing to condensing. Out to 2050, what does that look like? So again, this is draft and may well change. So again, here's our 2030 mark from before. Out to 2050, we're expecting to see perhaps a slightly slower, more gradual decline in gas demand beyond 2030. But that's looking at the minute like a 30% reduction in annual gas demand by that period. We're still exploring this beyond 2030 period and considering some other assumptions to see what impact it has on this. But in terms of why there's such a big change between pre-2030 and post-2030, that's predominantly down to getting rid of non-condensing gas boilers. So this, combined with some insulation assumptions, has quite an accelerated reduction in gas demand to 2030. Beyond 2030, I think what we're seeing is some condensing gas boilers shifting to fuel cells and micro CHP. That might actually increase gas demand in those properties. But it's quite interesting to see that even as the installed base of these appliances change, gas demand might only go down gradually and slowly to 2050. So as I say, this is early analysis. We'll be doing more analysis around this to see what sensitivities might either accelerate that or slow down that gas demand reduction post 2030. So that's just some of the headlines on Flanders. In terms of what's next, we're currently doing the same research for Wallonia and for Brussels. So we're finalizing the draft results and we'll be sharing that with GasBE shortly. And we'll be doing some sensitivity analysis just to see what impacts this gas demand going forward. That was all residential focus. The add-on to this study this time is we're also doing the same for commercial and for industrial heating as well to see what impact changes here will have in gas demand out to 2050. Provisionally, we'll be looking at these sectors for commercial and these sectors for industrial. But we've just started this research, so I suspect we'll probably deprioritize or maybe add in some other sectors here as we do some of the analysis around this. I would love to speak to the audience today or have some conversations afterwards to get your thoughts on what you've seen for our residential analysis, and certainly to hear what you think could happen in commercial and industrial just to feed into our analysis today, so please feel free to ask questions afterwards or come find me. And those are my details, so any questions, happy to follow up afterwards. Thank you.